Chapter 9 is about transformational geometry, and we're going to start off with reflections. So by the end of this lesson, you should be able to identify and draw some reflections. Isometry is a transformation that does not change the size or the shape of a figure. They're also called congruence transformations or rigid motions. So it's important to notice this word here. This means that everything we do is going to be congruent. You're going to start with a pre-image for all of these things. And you're going to get an image, and they are going to be congruent. So these three types we went over in chapter 1, and we're going to revisit them now. You have reflections, translations, and rotations. Reflections, remember, just flip across any given line. Translations are sliding, and rotations are turning around. So the original figure is always called your pre-image, and then the resulting figure is called your image. And remember, we use normal notation for pre-image, and once we've done something to it, we put these little slashes here, and we call them primes. So point A got moved to A prime, point B to B prime, and C to C prime. And then this was from chapter 1 as well. So reflections a flip across the line, rotations a turn about a point, and translations a slide. But you can go through and read their whole definitions if you need a refresher. So let's start off easy. Tell whether each transformation appears to be a reflection and explain. So reflection would mean that it would have to be flipped over some line. If you look at this first figure, it doesn't look like it was flipped. This guy is closer to the right, and it's the same on this side. So it doesn't matter where we flip it over. It looks more like it was just slid across here. So this is not a reflection. And then we can just say it was slid to the right. Now in this one here, if we start with the red one and we get the blue, or the other way around, we can clearly see that it was flipped over some line right here. If we fold our paper on that dotted line right there, we get the other image. So a reflection is a transformation across a line called the line of reflection. The line of reflection is always the perpendicular bisector of each segment joining the point and its image. So let's say I started with point A and I made it to A prime. The line of reflection is directly in between those two, and it's perpendicular to this segment that I just created. So we're going to use that to do some reflections in the coordinate plane. And tomorrow in class we'll do some just on a piece of paper. So sometimes our lines are as simple as the x-axis or the y-axis. If something's across the x-axis, when you're taking a look at the points, the x value is going to stay exactly the same because we don't move it right or left. But what's going to change is the y value. We're going to shift it from positive y to negative y, or the other way around. And then across the y-axis is exactly the opposite. So the x value is going to change, but the y value is going to stay the same because we're not moving up or down any. So if we started over here, we count how many spaces were here, and then we go in the opposite direction. And then the other one that we're going to do a lot of is the line y equals x. And now this is the line y equals mx plus b, where our m, or our slope, is 1, and our y-intercept is 0. And this line is special because y equals x exactly at this point. So what happens when you flip something over this line is your x and y values and your point just totally switch around. Your input becomes your output and the other way around. So reflect the figure with the given vertices across the given line. So let's start with plotting what they give us. R is at -2, 2. S is at 5, 0. And T is at 3, -1. So if we were to connect these, we get this very obtuse triangle here. And we have to flip it along the line y equals x. So if we draw that line, it has a slope of, or a y-intercept of 0 and a slope of 1. So we can draw this line on here. And we could get into figuring out the perpendicular part of this and then moving it, but we know when something crosses this line, the x and the y values just change spots. So r prime is positive 2, negative 2. S prime, let's flip these around, is 0, 5. And then t prime, again, switch these around, is at negative 1, 3. So then let's plot this one. Over 2, down 2, here's going to be r prime. S is at 0, 5, so up here this time. And t is going to be at negative 1, positive 3. And if we connect these dots, double check that this looks right to you. So we have this triangle here that had to be flipped over the purple line, and we started with this triangle here. So we can kind of see that they match up a little bit, which is exactly what we want. Oh, this r isn't in the right spot. This should be at, what was it, 2, negative 2? It should be way down here. There we go. Now it looks a little better. So we can see that it kind of just flip-flopped. If we were to fold our paper in half, we would have gotten this point to move up here and like this point to move right here. So next one, we have x, y, and z. So x is at 2, negative 1. Y is at negative 4, negative 3. And z is at 3, 2. So again, we have a very obtuse triangle. But this time the line that they want us to reflect it over is the x-axis. So that's this guy right here. And remember, when you flip something over the x-axis, the x values are going to stay exactly the same. The only thing that changes is the y values, because we don't want to shift it left or right any. So we can make our primes. X prime, we're going to leave our x values alone, so 2 stays the same, but you change the sign on this one. So change the sign from negative to positive. Y prime, again, we leave our x values alone, but we change the sign on the y value. And z prime, leave the x alone, change the sign on the y value. And then we can plot this. So over 2, up 1, that's our new x value. Y is at negative 4, positive 3. This one's a little easier to do like on your own without making up the points. 3, negative 2. Because it's kind of obvious where these ones should go. And then this, and then this. So again, double check that what you drew looks like it should. And again, had we taken our paper and folded it along the line of reflection, it would have been right where we made it. And that's it for today. You should be able to identify and draw some reflections. Write down any questions if you have them. We can go over them in class tomorrow. Enjoy your night.